Okay, so now we're going to get into the coolest thing in all of math, and that's how you actually solve equations. So the way that we do that is we're going to use two properties, first of all, called the addition property of equality and the subtraction property of equality. Now basically what these mean is Mr. Boyer doesn't know English, but what they really mean is that whatever you do to one side of the equation, you do to both sides of the equation, and you haven't really changed anything. You will have an equivalent equation. So I can add and subtract the same number from both sides of an equation. By doing that, we can isolate the variable, get it by itself. And we do it using inverse operations. So whatever I see, I do the opposite to both sides. So for example, x plus 14 equals 35. What's the opposite of x plus 14? X minus 14. So I can do that to both sides without changing this relationship. So I get x by itself because plus 14 and minus 14 cancel. And then 35 minus 14, well, I think that's going to be what? Is that going to be 21? I believe so. So I think that x equals 21. Now we do have to check our work just to make sure, because we always check our work. So I'm going to take the 21 and plug it up into the original problem here. And I'm going to put a question mark because I don't know if it's true. I want to make sure that I did everything right, make sure that it works. So 21 plus 14, I think that is going to give me 35. Equal to 35. Since I got a true statement, I correctly solved the problem. Let's do another one. I have d minus 4 on one side and negative 5 on the other side. I want to get the variable by itself. So the opposite of subtracting 4 is to add 4. So that's what I'm going to do. I'm going to add 4 to both sides. And the 4's cancel here. Negative 5 plus 4, I have to solve that. So negative 5 plus 4, okay, I've got opposite signs here, and I'm adding. When you have different signs, you find their difference. I mean, I suppose you could use your calculator, but if you don't use it, that means you're extra cool if you don't use it. So negative 5 plus 4, I get negative 1, because the difference is 1, and I keep the sign of the bigger one. And then on the other side, I have d. And what you can do, just to make it look nicer, you can reverse the two sides here and put d on the left. So my answer is d equals negative 1. Now we want to check this and make sure that it works. So I have negative 1 minus 4. Well, negative 1 minus 4, to check that, you could do negative 1 plus negative 4. You add the opposite. Negative 1 plus negative 4, signs are the same. You add the numbers and keep the sign. And I get negative 5 on one side, and I had negative 5 on the other side. So it checks. So my solution was d equals negative 1. Just like here, my solution was x equals 21. So whatever you see happening, you reverse the operation that you see happening. You do the opposite, and then you get your answer. And you make sure you do it to both sides, and then you check your work. So couldn't be any easier than that. Okay, let's do another problem here. I've got x plus 3.5 equals 7.2. So what's the opposite of add 3.5? You got it. Subtract 3.5. So I will do that from both sides. Always do it to both sides of the equation. You got to balance the scale. Okay, and for this one, if you want to, you can actually use your calculator. So I have 7.2 minus 3.5 equals 3.7. Those 3.5s cancel, and I get 3.7 on the other side. And x is now isolated by itself. So I think that's my final answer, but I'm going to check my work by plugging this 3.7 back into the original problem and seeing if I get a true statement when I do that. So I'm going to take 3.7 plus 3.5 equals 7.2. So I got the same thing on both sides, true statement. So this was my correct answer, except I don't like that color. I'm going to make it blue, because that way I'm going to circle my answer in red, just so it stands out, because it's a really beautiful answer. Okay, let's do one more. I have m minus 2/3 equals 3/4. So I am going to add 2/3 to both sides. And the 2/3 cancel, and I get m equal to 3/4 plus 2/3. Now, we can do this by finding a common denominator. I would like to do that. So 3/4 plus 2/3. Common denominator, well, I can change both a 4 and a 3 into what? What's the smallest number? I think a 12. So I'll change them both into 12s. So when I do that, I get 9/12 plus 8/12, and that equals 17/12. So my answer is 17/12. And notice my variable was on the right. I immediately wrote it on the left, just because that's how we like our variables to look, and we can check our work. So we rewrite the original problem now. So I'm going to put 17/12 in for m and subtract 2/3. And if you want to use your calculator for the checking, that's okay. But the first time through, I think we should do it without, just because, you know, people who don't use their calculators all the time are pretty cool. So you want to be one of those cool people. All your friends be like, man, this guy is, their brain is their calculator. Okay, so I have 17/12 minus, and then here I have 2/3. Okay, and I get 3/4, so I have 3/4 equals 3/4. That's a true statement. That means this answer was correct. And what could be better than that, you know? So I'll talk to you real soon here.